center? Instant means at a particular fixed instant. That's what it means. So suppose an object is there, and at some point this point is moving this side, and this point is moving. Screen is not visible now. Yep. So let us see, these two objects are moving like this. So one point is moving that side, one point is moving this side. So if we draw perpendicular at both these places, okay, this point is called as center of rotation, right? And if the velocity direction is changing continuously, then this is the center for this instant. The next instant it may be changing, next instant again it may change, you know. That is why this point is called as instantaneous center. Okay, that's why it's called as instantaneous center, because at every instant it is different. At this instant this is the center. Yeah. And from the diagram you can see how to find the instantaneous center. So if you know the velocity of 2 points, let us say A and B are the 2 points, and if you know the velocity at A and velocity at B, then all you have to do is you have to just draw perpendiculars from both the velocities. Their intersection will give us instantaneous center. Okay, and the good thing about this is that once you find the instantaneous center, the rotation about this point, omega, will be same for all the points. Yeah. So once you find the instantaneous centers, let us say you know the value of omega velocity b, and you want to find a velocity a. So we can easily find that by omega relation. So omega is equal to velocity a by radius of a. That's also equal to velocity of b by radius b. Okay, and let us say if you want to find velocity of another point c, that also you can just put velocity of c by radius of c. What is RA? RA is this distance. Okay, RB is this distance, right? RC, if you will have this distance, right? This is the power of instantaneous center. Okay, and I think that's what you will study next. Where did it go? Here it is. Okay, so first is locate the instantaneous center. Okay, just now I told you how to find instantaneous center. Then of zero velocity, what is this? You teach that here maybe. So let's see what happens. And apply the instantaneous center to find velocity of any point. So just now I explained that also. Determine the velocity and acceleration of a rigid body undergoing general plane motion using absolute motion analysis. So these three things we have to do. So for any body undergoing motion, there always exists a point in the plane of motion at which the velocity is instantaneously zero. Velocity is instantaneously zero. This point is called. Okay, fine. What it means is, here we have done the analysis now. So the velocity of this point will be zero. Okay, the velocity of any point will have some velocity at least, but the velocity at this point will be zero. Okay, that's why he is calling it as instantaneous center of zero velocity. Actually, in India, here we don't use this term. We just use instantaneous center. That's why I wasn't able to make connection. Now it's clear what it is, right? And he's explaining here what this is. It's written as IC. IC means instantaneous center. Now for the bicycle wheel, the instantaneous center will be at the point where it is making connection with the road. Okay. Then yeah, if you have a ladder which is sliding on the wall and on the ground, for that instantaneous center, again it will be we have to draw perpendicular to both the velocities now. VA is horizontal, so its perpendicular will be vertical. VB is vertical, so its perpendicular will be horizontal. You know, the intersection of both will give us the instantaneous center. Then location of instantaneous center. Velocity of a point on the body is always perpendicular to relative motion. Okay. In this case, IC is located along the line from perpendicular to VA. So we just have to draw perpendiculars to the velocity. We have to just draw perpendiculars to the velocity, and yeah. So if you know velocity at 2 points, then those perpendiculars will intersect at some place. That point of intersection will give us instantaneous center. For example, here you can see the point A is moving downwards and point B is moving this side. If you draw perpendiculars from both these, you will get intersection. That intersection point is IC. At IC, the velocity at IC is 0. Velocity at A, some value will be there. Velocity of B, some value will be there. Then location of instantaneous center once again. So some cases are given here. First case it is like this. Second case it is like this. And 2 points we are known. Third case, let us say A and B are 2 points. A is moving right side, B is moving left side. Then to find instantaneous center, we have to join these 2 points. And the point where this intersects will give us instantaneous center. And let us say 2 points are like this, A and B. They are moving in the same direction. And the velocities are parallel. And again, we need to make a triangle. Okay. The apex of that triangle will give us yes. If they are parallel, we have to make the triangle. If they are in opposite directions, we will get triangle in opposite sides. If they are in same direction, we will get no instantaneous center on the other side, on the side of the lower velocity. And location of instantaneous center. Okay, so here you can see A and B both are moving parallelly. It's a slider, no? So the instantaneous center will be at infinity, because both velocity of A and velocity of B are equal and both are parallel to each other. So if you draw perpendicular to both the velocities, they will never meet, they will be parallel. It will be at infinity. At least if one if one velocity is different from the other, then we can form a triangle. In this case, triangle is also not possible. That's why they'll be at infinity. Then we have another body here. 3 velocities are known. This is what we get here. So here we have an example. Ready?
हो चालेल.
Ready for the problem? Okay. Sorry. At B, instantaneous center. So you have to give them some numbers. So let's say 1. So the fixed frame is 1. This is 2. This is 3. And the slider is 4. So instantaneous center between 1 and 2 will be located here. Instantaneous center between 2 and 3 will be located here. So IC between 3 and 4 will be located here. And IC between 1 and 4. What about 1 and 4? 1 and 4 will be located at infinity. Okay. One minute. Ready? इधर है अंदर. Okay. So for instantaneous center, we need to put dots like this, and then do the numbering here like this. Yeah. And then every dot should connect every other dot. That will give us the total number of instantaneous centers. Okay. So 1 and 2 are connected. You got this here, you know. Then 2 and 3 are connected. We got that center here. Then 3 and 4 are connected. We got the center here. 4 and 1 are connected. We got it at infinity. Next, 1 will also be connected with 3. Okay. So how to find 1, 3? How to find 1, 3? So for 1, 3, there is a theorem called Kennedy's theorem. I think you are not taught about that. What's the question here? Let's understand that. And if there is a need for that, we will come to it. Linkage undergoing motion is shown. Velocity of block VD is given. Angular velocities of AB and BD are required. Yeah, so we will need the instantaneous centers of the other two also. There is a theorem called Kennedy's theorem. If you want the instantaneous center of 1 and 3, 1 and 3, it will be at a point like this. You have to extend this. Okay, so this is the instantaneous center of 1 and 3. Okay, I'll just write it as I13. I14 is here. Okay, I23 is here. I12 is here. I13 is here. And then if you want, what is left? I24. Okay, if you want 24, then you have to extend it backside. This you have to extend it backside. Okay, got it? This is instantaneous center 24. Okay. So okay. So here we have to find this omega. Okay. That omega. This will be the omega for link BD. Okay. For that we need this length D to I13. How to find D to I13? So we basically use graphical method here in India. I don't know how he expects you to do it. Let me see here. Yeah, so he is building a triangle here, you can see. And sorry, BD is link number 3. So for link number 3, we will get instantaneous center here. And we know the information that this is perpendicular, right? And if this is 45, this will also be 45. So whatever is the length BD, the same length will come here. This length will also be 0.4 meters. Okay. And this vertical length will be how much? 0.4 into root 2. You know? Now that this length is known, we can find omega. So omega for BD, omega for BD will be equal to velocity of D divided by the length D to I13. Okay. So for you, he has just written it as IC. In your book, it is written as just IC. Okay. Here also I can just write IC. Okay. Velocity at D is 3. Then this length is 0.4 times root 2. So find this, you will get omega. Okay. What did you get? E divided by 0.4 into square root 2. 5.3 now. 5.3, 5.30 radians per second. Next, he is asking the angular velocity of BD. No, BD is over, no? BD is over. AB he wants us to find. Yeah. So this is over. We have to find AB next. Amma? Angular velocity we need to find. Angular velocity of AB. Yes, yes. So velocity we will need. So which velocity can you find is the question. So can we find velocity of B? Velocity of B will be equal to omega into this length. What is that length? BIC. Okay. this length. Omega into this length will give us the velocity of b now. So this velocity, that velocity we found just now, right? This velocity used here, 5.3 into this length. That length is 0.4 now. What do we get? 2.12. So this is the velocity at b. This is the velocity at b. Okay, and it will be in this direction, right? It will be in this direction. So now now we need to use this. Okay, so now we need to use this velocity at b, to find omega of ab, omega of ab. Okay, of ab. Okay, omega of ab will be equal to velocity at b divided by ab. Yes, because here it is perpendicular now. Because it is perpendicular, we can directly take it with this. So VB is 2.12 divided by AD length is 0.4. So what do we get? 5.3 radians per second. Okay, velocity of BD 5.3, velocity of AB is again same. Okay, next example. Okay, so we have center O of the gear set rolls with velocity 6 meter per second. Gear rack B is fixed. Okay, so the rack B is fixed and the center O of the gear set rolls. Okay, so the center is traveling on the right side. Okay, 6 meter per second. Velocity of point A he is asking. On the outer gear, outer gear means point A is here, huh? Sorry, I didn't get you. Opposites. What opposite? It's rotating, so peripheral velocity at this point it will be upwards. At this point it will be right side and so on. So we know here for sure that this velocity is in right side direction. No? So when this point O moves in right side direction, the gear will rotate now, and the rack is fixed. Rack is fixed, and yeah, because the teeth are meshing, it will rotate like this. So both both the gears are welded together, so both of them rotate with same angular velocity. So first here we know the velocity. Let's say this point, let us call it as B. So velocity of B will be omega of B into radial distance. Radial distance is 0.3 now. Velocity of B will be same as this value, right? That we can substitute and find omega B. Omega B is how much? VB by 0.3. So 6 by 0.3. What do we get? Huh? 20 radians per second. Then velocity at A into its distance. The distance of that is 0.6, and it will be equal to velocity of B into 0.3. Now we can find velocity of A. Omega A equals, this will go away, this will go away, 1 omega B by 2. Hey, 1 minute. Don't be that way. Angular velocity of A and B both will be equal now. Angular velocity of A and B both will be equal. Linear velocity will be different. Linear velocity at linear velocity at A into its radial distance. Radial distance is 0.6. But omega A and omega B will be same, no? 20 into 0.6. 12 meter per second. Because the point A is this side, horizontal, it will move upwards. It will move upwards with 12 meter per second. He's using instantaneous center method to find it. Find it slightly different. So here this is just the upward component. Here it is the upward component. It will also have a horizontal component. Okay, and combining them both will give us the total velocity. So if you do by component method, it is complex, right? So answer will be same, but methods are different. So you have been asked to use that method particularly, no? So that we need to use. So if A is joined here, that will give the instantaneous center. This is the instantaneous center. Okay, so that instantaneous center we should use it. So here this omega will be same. So that omega will be let's say velocity of A is this direction, velocity of B is this direction, right? So this will be velocity of A divided by radial distance. This distance is how much? This distance is 0.3, no, radius of smaller gear, no? And yeah, so this distance is 0.6, no? This distance, okay, 0.6. So that we need to use. Omega equal to VA divided by this length. How much is this length? This length is how much? This is sorry, this is the hypotenuse, no? Adjacent is this, opposite is this. You can use the Pythagoras relation. 0.6 square plus 0.3 square under root. Do we get? 0.69. Okay. 679, no? Right? Let's try it again. 0.6 square plus 0.3 square. 0.67, है ना? So this is 0.67. 0.67. Okay. So that same value we need to use here. 0.67. Okay. And that will also be equal to velocity of B divided by this length. Okay. This length is how much? That length 0.3 root 2. Okay, because you see both this length is length is 0.3, no? This length will also be 0.3. We are interested in this length. This is the value. Velocity of B is known. Here the point where it makes contact, wherever wheel makes contact with the ground, that point becomes instantaneous center. From there we need to angle. Let me show you with a different color. Okay, we have a triangle here and we have a triangle here. Take another. Okay, yes, on the ground at the point of contact. So we got the relation between VA and VB, but at least VB we should know, no? We know VB, then VB is no, no, that is not VB. I think because if it is no perpendicular to the center of rotation, then it is 6. Here it is acting at some other angle, right? Won't be that simple. Hmm. Again, what is given? R8 twice. Omega is taking it as 20. Omega V naught by PT. Okay, so omega of this he is finding. That we found now just now. Omega B. Next is using the same omega here. Okay. Yes. Yep. Now if you want to find VA will be equal to omega into 0.67. That is 20 into 0.67. What do we get? 13.4. Sorry, this is in meters per second. No? Okay, so this is the velocity of A. That's it. Same way, if you want velocity of B, again substitute omega 20, multiply with 0.3 root 2. That will give us velocity of B. Okay. Next. This is clear? Absolute motion analysis. Translation and rotation. Motion analysis. Procedure. An example. Oh, sorry. This window is opened up. Cylinder extends at a constant rate. Mm. Mm-hmm. Mm-hmm. Velocity at this point is given here, right? Velocity is moving here. This velocity B is given to us. That is 0.5. Okay. and the angular velocity and angular acceleration of a window. This point here is fixed, no? What we can do is we have to first find this angle. Okay, this angle we need to find, and when we find that angle, 2 meter, 1 meter, 1 meter. Yes, yes, length is given. Theta is given as 30 degrees, no? Theta is given as 30 degrees. Mhm. This, this, this angle is 30 degrees. This length is 2 meters. This is 1, 1. This is yes. Okay. This is the direction of velocity, you know. This is 90 degrees. This is 30 degrees. Because this is perpendicular, no? Once we know, sorry, once we know this component, we can find omega here. That's the reason I'm trying to find that. Yes, length is not given, no? Find this. Oh, okay, he's using the cosine rule. With cosine rule, we can find the value of yes. Okay, so c square angle c is opposite side of c. We want this, so angle opposite of that is given. So we need to use s equals 1 square plus 2 square plus 2 times 1 into 2 into cos of theta 30 degrees. One length is 1 meter. For second one, length is 2 meters. Exactly same. So 2 into 1 into 2 into cos 30. Okay. This should be under root, no? What we get? Yeah, 2 times cos 30. 2 into 2, 4 times cos 30. So 1 plus 4 is 5 plus 4 into cos 30 is root 3 by 2, no? I think it will cancel. Now we have to take it, calculate it. What do we get? 5 plus 2 into square root 3. 2.991, let's round it up. Okay, this is 2.91. We need the angle here. We know the angle we can do directly. Mm-hmm. If B perpendicular in this direction, perpendicular to this. Mm-hmm. What we need to do here? Yes value is getting different in the one square plus four square five. Two root three now. That's correct. So this is minus. This is supposed to be minus. Okay. Get it? This is supposed to be minus. Yeah, cosine rule is like that. It is supposed to be minus. So here we will get 1.239. Next, we need to find rotation. Mm-hmm. So we need to connect this yes with the displacement. If you want to connect this to displacement, you have to write the equation of yes as a variable. If you want to write it as a variable, it will be 5 s square equal to 5 minus 4 cos theta. है ना? So now if we want velocity, we have to differentiate this. What do we get when we differentiate? Differentiate with respect to time. S square differentiation will be 2s into ds by dt, है ना? Equals 5 is constant, so differentiation will be 0. Then minus 4 cos theta differentiation is sin theta, na? Minus sin theta. Differentiation of cos theta is minus sin theta. So it will be just 4 cos theta. 2s into ds by dt. What is ds by dt? This is velocity. That velocity is given in the question. This velocity is given as 0.5. And this 2 times yes. What is yes? Yes is the length. 1.239 equals 4 cos theta. Right? Here it becomes sin theta now. Negative negative will cancel. Two negatives. Minus and minus plus sin theta. 4 times sin theta. So this sin theta, and here one more term you will get, na, d theta by dt. Correct? So that will result in omega here. That will result in here. Okay, so now simplify this, cancel, simplify, and we can find velocity. Which velocity? We can find omega. Find omega. Omega equals this 2, it cancel with this, 1.239 into 0.5 divided by 2 sine 30. No, theta is 30. Find omega now. Got it? 0.619, yes. Radians per second. This is the angular velocity. This is the angular velocity. Is also asking angular acceleration. In order to find angular acceleration, we have to differentiate this equation once again. Okay, differentiate 2s into dv by dt, you know, plus velocity s into 2 ds by dt. Okay, this is equal to, sorry, angular, this one. Here again we have theta and omega, both are changing, so sin theta into d omega by dt plus 4 omega, and this will become cos theta d theta by dt. It's very complex, huh? dv by dt is acceleration plus vs square, 2 times vs square, equal to 4 sin theta d omega by dt is theta, dt is alpha, plus d theta by dt is omega, so omega square cos theta. Okay, so many things. Omega we found, theta we know, vs, do we know vs? Yeah, 0.5, vs is 0.5, and here acceleration is 0 because he is telling vs is constant. Okay, so vs you can substitute, theta is known, omega is known, theta is known, so alpha is the only unknown. Find it. Getting it? Yeah, 4 omega square. Omega is 0.619 or 0.62 you can take. Much? How much? 825. Oh. Check. Have you made any mistake anywhere? Yeah, you have to square it. Square it. Got it? Yeah. Yes, correct. Yeah. Next one is on a valve. Okay. So the valve circular cam is rotating clockwise about O, constant velocity omega. Velocity and acceleration of the follower as a function of theta. So this is a derivation. We can just note it down as it is. Okay. This finishes this particular lesson. Any doubt? Okay. Sorry. Shall we stop here? Okay, madam. Tomorrow same time 8.